Hello friends, today let us see a problem on a property of DFT or how to apply property to a given problem in DFT. Now let us say the given x of n is 1 plus 2j, 1 plus 2j, 1 minus 1 plus 3j, 2 plus 4j, 2 plus 2j. This is a given sequence and it has been asked that from basic definition, find x of k. Then they are asking if x1 of n is equal to 1, 1, 2, 2 and x2 of n is equal to 2, 3, 4, 2, then find x1 of k and x2 of k by using DFT only once. So now we are actually required to find three sequences: x of k, x1 of k and x2 of k. But in the problem it has been mentioned that I can use the definition only once. That is, when I am finding the sequence x of n k using x of n as an input, that time I can use the definition. Rest of the time I need to use properties. So whenever in the question it has been mentioned that use DFT only once or using the previous solution and not otherwise, such words are indicating that the problem is of a property. So we have to use property in that problem. Even though if you will solve the problem using definitions, you will get the answer, but the solution will not be graded. That is because the properties need to be tested in such type of problems. So let us first apply. Let us start solving this problem. So for the solution, my given x of n is 1 plus 2j, then it is 1 plus 3j, then it is 2 plus 4j, and finally it is 2 plus 2j. Now using the definition of DFT, I will get x of k equals to summation n going from 0 to n minus 1 x of n w n raised to nk. Now in this problem, n is nothing but 4 because we have 4 set of samples. But instead of using the formula based method, we will use matrix method. So we'll be using matrix method. So when I'm using matrix method, I'm going to get on the left hand side capital X of 0, capital X of 1, capital X of 2 and capital X of 3. Whereas on the other side, because it's a 4 by 4 matrix, it is 1, 1, 1, 1, 1, 1, 1. So first row, first column, all ones. Then we have minus j, then we have j, then we have minus 1, minus 1, minus 1, minus 1, and the center element is 1. This will be multiplied by 1 plus 2j, 1 plus 3j, 2 plus 4j, and 2 plus 2j. So let us do the matrix multiplication. So the matrix multiplication will give me the row multiplied by the column. So x of 0 will be equal to first element to first element. So I'll get 1 plus 2j plus the first element to the second element, it is 1 plus 3j. Then the first element to the second element, which is equal to 2 plus 4j, and then lastly 2 plus 2j. So that comes out 1 plus 1 2, 2 plus 2 4, 4 plus 2 6, and then with the j elements is 2 plus 3 5, 5 plus 6 is 11. So I'll get plus 11j. Then let us go with x of 1. For x of 1, we'll be multiplying the second row with the given column. So when I multiply 1 with this column, it is 1 plus 2j. For when I multiply this with the second element, it will be minus 1 minus 3j. Then minus j minus 3j square, because I'm multiplying by j, to 1 is minus j. J with 3j will give me minus 3j square. Then I have minus 1 multiplied by the third element, so that will give me minus 2 minus 4j, and the last element will be plus 2j and plus 2j square. Okay, so we will rewrite the things. It is 1 plus 2j minus j. So j square is minus 1, so this becomes plus 3 minus 2 minus 4j plus 2j. 2j square will give me minus 2. So the final answer will be minus 2 is minus 4, minus 4, and this plus 4 will get cancelled. So this 3 1 4 and this is minus 4 will get cancelled. Now this is plus 2j will give me 4j, and here we have minus 4j, so this will also get cancelled. Ultimately what remains is minus j. Agreed? Similar way, if you found x of 2, then I will get 1 plus 2j. Okay, minus 1 multiplied by this becomes minus 1 minus 3j plus 2 plus 4j minus 2 minus 2j. So now here plus 2j minus 2j will get cancelled, plus 2 minus 2 will get cancelled. I have minus 1 plus 1 getting cancelled, and here I have minus 3j plus 4j, so answer will be j. Okay, and lastly we wanted to find what is x of 3. So for x of 3 we can solve x of 3 as last column and first row. So last column first row will be 1 plus 2j, okay, this one, then plus j plus 3j square minus 2 minus 4j and minus 2 minus 2j square. Okay, so this will give me 1, right, plus 2j plus j, this will give me minus 3 because j square is minus 1, minus 2 minus 4j minus 2 minus of minus plus 2, right. So now here you can see that is minus of minus 2 is minus 4, so or you can cut this 2 out. Then we have minus 5 plus 1, which is this is minus 5 plus 1, which will give me minus 4, and then we have minus 4 plus 3j, which is minus j. So we will recheck it. It is minus 4, j plus 2j is 3j. So plus 3j minus 4j will give me minus j. This minus 5 plus 1 will give me minus 4. So the total x of k, in this case, the total x of k is given as, the total x of k is given as 6 plus 11j, then we have minus j, then we have plus j, and lastly we have minus 4 minus j. This is what the solution of x of k. Now since we get x of k and we wanted to find, now since we have obtained x of k and we wanted to go for x of 1 of k and x of 2 of k, so let us first write what is x1 of n. So x1 of n is 1, 1, 2, 2. So the basic problem that we started with is x of n is having the value as 1, 1, 2, 2. So with 1, 1, 2, 2 and x2 of n, we have the value as 2, 3, 4, 2. So 2, 3, 4, 2 is the value of x2 of n, and x1 of n is 1, 1, 2, 2. Now to apply any property, first I need to find the relation of x of n with x1 of n and x2 of n. So to develop a relation with x1 of n and x2 of n, let us closely observe what is x of n is. So x of n is nothing but 1 plus 2j, comma 1 plus 3j, comma 2 plus 4j, comma 2 plus 2j. Right, so that is what my x of n is. Now looking closely, we can find that all the real values in x of n corresponds to x1 of n. Can you see? So it is nothing but all the real values of x1 of n belongs to x of n, and all the imaginary values in x of n belongs to x of n. Right, so we can say that x2 of n is nothing but the imaginary part of x of n, and x1 of n is the real part of x of n. So this is how we build the relation of x1 and x2 with x of n. Now how to write an imaginary part and a real part in x of n, or how to separate this real part and imaginary part of x of n. So if suppose I wanted to separate out the real part in a given complex number, then if suppose I have a complex number x which is equal to a plus ib, and I wanted to separate the real and the imaginary part a and b, then let us take the conjugate of x, which will give me a minus ib. Right, conjugating means changing the sign of the imaginary part. Now if suppose I add these two numbers, that means I'm adding x of n plus x star of n, will actually cancel the imaginary part and will give me 2a. So what is a? A is nothing but x plus x conjugate divided by 2, where a is the real part. Similarly, if I subtract these two numbers, that means if I have x minus x star that means I'm subtracting these two numbers, then the A part will get cancelled and I'll get 2B and with the I. Okay, then I can write B is equal to x minus x star upon 2j or 2I. So that is nothing but my imaginary part. So to separate out the real part and the imaginary part from a given complex number, if we add its conjugate to it, then I am going to get the real part, and if I am going to subtract the conjugate of the number, then I am going to get the imaginary part. So similarly, I can write that x1 of n, which is nothing but the real part of x of n, can be written as x of n added with x conjugate of n divided by 2, whereas x2 of n is nothing but the imaginary part of x of n. It can be written as x of n minus x star of n by 2j. Right. Now I can apply a property on this problem. So now I got the basic input as this. Now we see addition and subtraction sign, which recollects me about the linearity property of DFT, as well as there is 1/2 scaling factor which comes out as a constant. So this DFT of the first equation, so DFT of equation 1 can be written as 1/2, which is a constant. X of n can be written as x of k. Plus sign will replicate as it is because of the linearity property. And this is nothing but the complex conjugate property, which says that x of minus k. That means we need to mirror image the signal, or x star of minus k. That means we need to mirror image the complex conjugate x of k. That is the first sequence output x1 of k. Whereas x2 of k we can write as 1/2j x of k plus, not plus, it's minus over here. So we have not plus but a minus x conjugate of minus k as the solution for x2 of k. So x1 of k and x2 of k can be derived from x of k by simply adding, conjugating, mirror imaging, dividing by 2 will give me x1 of k. In the second case, taking x of k, conjugating, mirror imaging, subtracting and dividing by 2j will give me x2 of j. Let us find what is x1 of k. So we know that x of k is equal to 6 plus 11j minus j plus j minus 4 minus j. That is what the solution of x of k. Therefore, x1 of k will be equal to 1/2 this complete matrix plus, now I wanted to conjugate and I wanted to mirror image. So let us take x conjugate of k. Conjugating a sequence is just replacing its j signs. So wherever it is plus j will become minus j, and wherever it is minus j will become plus j. So this is nothing but the conjugate of x of k, but I don't want conjugate of x of k. I want conjugate and folded sequence of x of k, which will give me 6 minus 11j and then the third sequence will come to the second place, which is minus 4 plus 1j and minus j as it is and plus j. So we have this as my x star of minus k. So we will add as 6 minus 11j minus 4 plus j, then we have minus j, and then we have plus j. Whenever we add matrices, we add element by element, and this whole matrice is added and divided by 2. So let me keep a larger bracket out of 1 by 2. So we will add these two numbers. I'm going to get 6 plus 11j plus 6 minus 11j. 11j will get cancelled. 6 will give me 12. When I divide 12 by 2, I'm going to get 6 back. So it will be 6. Next, minus j added with minus 4 plus j. Minus j plus j will get cancelled. Minus 4 divided by 2 is minus 2. Next, minus j added plus j added with minus j divided 0. 0 divided by any number is 0. Then minus 4 minus j added with plus j. J will get cancelled. Minus 4 divided by 2 is minus 2. So x1 of k is nothing but 6 minus 2, 0, minus 2. Similarly, we can find by keeping here minus and dividing by 2j the x2 of k. So I just replace the plus sign with minus and 2 with 2j, and the solution that we get is x2 of k. That is nothing but 6 plus 11j minus 6 plus 11j. So now the real part will get cancelled and you'll get plus 22j, which when divided by 2j will give me 11. Next, minus j minus of minus 4 will give me plus 4. So minus j minus of minus 4 will give me plus 4, and this will give me minus j. So it will give me minus 4 minus 2j when divided by 2j. Okay, I'll not solve that, but let's keep it as it is. Minus 4 minus 2j divided by 2j. Okay, you can write by splitting this 2j in the denominator as minus 2. That j once goes up becomes plus j. So you can write this as 2j, because minus j goes up. Denominator j when is taken to numerator becomes minus j, and minus 2 will convert to minus 1. Okay, so that can be solved as well. Then you have a j minus of minus plus 2j. 2j divided by 2j will give me 1 as an answer, and finally we have a minus 4 minus plus 4. This is minus 4, then this is plus 4. Minus 4 plus 4 will be 0, and then I have a minus of minus, that is 2j. 2j by 2j will give me 1 as an answer. So this is another sequence x2 of k. So we got x1 of k and x2 of k both solved using x of k alone, without using the definition twice. So we have used the definition only once while calculating x of k, but x1 of k and x2 of k is found without using the definition, but by finding the relation and applying the property. Thank you.